And so without further ado, today's speaker is David Litchfield, and today's talk is Find Me in Your Database.
Hey, good morning everybody. Thanks for coming. I hope you're enjoying your stay in Las Vegas so far. It's just about to get even better. So, today's talk's going to be about index security on the Oracle database server. Find me in your database, it's supposed to be a bit funny, like I owned you, so you can find me in your database, but also look me up in your database because it's index-based, you know. But so let's get on. So who am I? I've been kicking around the industry for probably about 15 years now. Primarily, I'm a vulnerability researcher. I started out in buffer overflow exploitation a long while ago, about 15 years ago, or probably about 12. I knew about this thing called buffer overflows. It was this magic thing that I didn't quite understand. And I was playing around with the remote connection manager, the RAS service on Windows NT, and I put a long string of A's in the RAS phone book, basically, and started something off, and this access violation kicked off. Address at 414141, reference memory at 4141. It's like, wow, that's one of these buffer overflow things, these magic things that people keep on speaking about. So I taught myself how to exploit a buffer overflow, and as I was doing that, I wrote a paper on it, exploiting Windows NT for buffer overflows, a tutorial and everything like that. And I cringe now when I go back and look at that paper because it's evident that I don't fully understand the idea. I get code execution and everything, but you know, the whole concept of overwriting the save return address and this, that, and the other, it's just not in there. It's plainly just not there. So yeah, I cringe when I go back and read my old papers, but it suffices. So anyway, moving on from there, I started looking at the Windows 2003 stack protection stuff and wrote a paper on defeating that. And afterwards, I moved into database security. I was starting to look at Microsoft SQL Server 2000. I discovered the flaw that Slammer exploited and presented in May 2002 and presented some shellcode to demonstrate the exploit or how dangerous the flaw was in SQL Server. And then the people who wrote Slammer took my code and used that as the template. So it was, it caused me to question what I was doing at the time. So anyway, eventually Larry Ellison turned around and said his product was unbreakable. And I laughed and laughed. And after I managed to stop laughing, I started researching the database. And my brother and I, between us, sent within the 24 hours of Larry Ellison saying that about 35, 36 different flaws that allowed some really silly ones, like an overly long username will allow you to cause a stack-based buffer overflow and gain full control over the Oracle database server. And this is an EAL 4+ certified product at the time. So it's sort of just, you know, as far as the common criteria is concerned, you just had to read the database protection profile to understand that, you know, no real thought had gone into actually securing it. I think the protection profile says this only works if you're on a non-hostile network. Well, you know, what's that worth? So I then started getting into database forensics, and because I realized that no matter what you do, at some point you're still going to get owned. And I think some of the work done by Anonymous recently has shown that, you know, we need to understand how to find out when hackers break in, what they've done when they've got there, how they did it, and what we can do to prevent them from doing it again in the future. So I founded a company called Verity, and that was recently acquired by Accuvant, who is my current employer. And some other stuff I've done. I've written some books. And if you want to follow me on Twitter, I sometimes tweet about security stuff. I sometimes tweet about sharks, probably more often the sharks than not. And if you want to contact me about any of this stuff, my email address is dlitchfield@accuvant.com. So, without further ado, we can skip that slide. Yeah, this is the quick overview of what we're going to do today. Quick overview of what indexes are in the database and stuff. And then look at some of the weaknesses in the Oracle's version of indexing, and then demo some exploits. Now, unfortunately, this was a video which is no longer playing, so I'll describe what happens. So there's a wee dog yapping, and Oracle says, this is an unauthorized user, and then there's a cake, and they said, this is your data, and the cake is on top of a nice table, and then this little dog is trying to get the cake, and Oracle says, we're unbreakable, the dog can't get the cake, kind of. Now, it would be so much funnier if I could show it to you as opposed to me explaining it to you, but since we have no video, you're left with me. Do I get an Oscar for that, by the way? No. Thank you. That was my little dog impression, by the way. Yeah, George Hulme sent me this video, so I was going to include it. So the motivations is basically trying to improve Oracle's software, or any database software for that matter, including Microsoft, including IBM and everyone. So if we look at flaws that can be exploited specifically over SQL.NET, in other words, we're not interested in the HTTP flaws, we're not interested in this, that, and the other. The only ones we're interested in are the ones that are exploitable over SQL.NET, okay? And the amount of flaws that Oracle have patched, oh, by the way, each one of these is one of their critical patch updates going back to July 2008, so the past 4 years, essentially. So we can see a marked improvement. Another thing, it covers Oracle 9i Release 2 all the way through Oracle 11g Release 2. The further you get to the right, the less 9i R2 stuff there is, simply because they desupported it. So we can see though a marked improvement. On the left-hand side, which is July 2008, they were fixing, with each critical patch update, which comes out every 3 months, between, well, at the worst, about 15 flaws every 3 months, just SQL.NET ones. And other than a blip a few months ago when they, had about 11, I think it was, they've done really well. So Oracle have done a great job in terms of things like Pl Sql Injection flaws. They're almost been hunted to extinction now. There's a couple, things like stack-based buffer overflows. Again, they've done a really good job. Their data flow tools and analysis are actually not too bad. But they seem to be, from what I can infer, led by what the security research part of the industry is doing. That's what they'll focus on and make sure that there's a few bugs in that area. But when the security industry the security researcher side turns to a new area that no one's looked at before, suddenly there's a whole bunch of low-hanging fruit again. And so, like for example, a few years ago, I started looking at the Oracle the Java implementation within the Oracle database server itself, and there was a couple of fluffy things around there. And then people have been looking at the index side of things, and again, suddenly there's a whole slew of flaws. In fact, one of the things we'll be speaking about, which isn't my finding, it's someone else's, is a whole new class which really hasn't been publicly discussed yet. Just to give you some context, this is Microsoft SQL Server in the same time period, covering since SQL Server 2000 and up to version 2 of SQL 2008. This basically is the amount of flaws. So that's how Oracle's doing, that's how Microsoft's doing. So it's a pretty good record. So everyone understands the concept of an index in the back of a book. If you don't, you should probably be in the kindergarten class down the road, but I'm sure everyone does. So an index basically helps us find stuff quickly. Now, the way it happens in Oracle is, by default, indexes in Oracle are known as B-tree, and what that essentially does is, well, before we even go there. So data in Oracle is stored in blocks. So they have a data file which is logically split up into blocks of data. Now, each block of data has rows within it. Now, what an index does basically is say which row and in which block you can find a specific bit of data. So let's say we've got a table with 1 trillion records in it, so people's first and second names. If we didn't have an index and we wanted to search for David Litchfield, we would have to go through every single block of data looking to see if David Litchfield record exists in that one, if it's not moved to the next block, and so on. Now, what an index will do basically is split up those, like Litchfield into, an order so that, say, A to M can be found over here, and N to Z can be found over here. And so Litchfield is somewhere in between there, and then the next level down, it's like a tree node basically with leaves coming out. The next level down will look between like F and L and so on, and then move down until we get to the end node that points basically to where the record for Litchfield can be found, or LITC, and then the remaining records and so on. So with only checking 3 or 4 nodes within the index, we can quickly locate through trillions and trillions of records. So that's why indexes are so good. They're created on pretty much like one or more columns. So as I said, we've got a first name and a last name. We might create an index that indexes those columns so we can look up based upon that information. Or we can have one or more indexes per table and stuff. Now they can be function-based as well. Now what I mean by that is we might want to uppercase Litchfield or whatever the username is before doing the search. So we could create an index that has a function embedded with it. And then there's domain indexes. Domain indexes are whereby we have a complex data type. So let's say we have an aeroplane. An aeroplane has things like a weight, it has a wingspan, it has a range, and all of these things might not be straightforward data. Then, for example, there might be blobs, there might be this, that, or the other. Now what we can do basically is create our own domain index, our own application domain that allows us to still have indexes that search through these complex data types. So we'll look at some of these in a minute. Okay, as far as privileges are concerned on indexes, to create an index on a table, one of the following must be true. We either need to own the table or create any index privileges, which typically you will not find on a system, or have the index privilege on a given table. Now remember I spoke about function-based indexes earlier. People who know about Oracle the lights should be coming on if it's not already on. If we have the index privilege on a table, we might be able to create a function-based index on that table, and if it's a function-based index and it's using auth ID, actually let's put the slide on, I'm jumping ahead. Okay, so CVE 2010-0902, this was discovered by a friend of mine who's given me permission to talk about this stuff, or this specific flaw. And so basically, if you look at the flaw, the system user, which is a very powerful user on the Oracle database server, had 2 tables, OLAP session cubes and OLAP session dims, that basically gave public the index permission. Public is everybody on the database server. Now, this affected Oracle 9i release 2 all the way through 11g release 2, and it was fixed in July 2010, but there was never any public discussion about this. Now, essentially, what the problem is, if we, as public, we obviously, as a user on the system, have rights inferred to, derived through that granted to public, we can create an index on these tables. Now, if we can create an index on these tables and we create a function-based index, we can specify what that function is going to be. And if we, say, write a function that specifies auth ID current user, that essentially causes that function to execute as the owner of the table, which in this case is system. So just a quick background on Pl Sql Injection. By default, Oracle Pl Sql code, which is like the way you develop SQL applications on Oracle, by default, it will run with the privileges of the definer. In other words, if I create a Pl Sql procedure or function, whatever, it will execute with my privileges. If, however, I don't want that, and I want to execute with the privileges of the person calling the function, for security reasons, then we can specify when we create the function or the procedure or the package for that matter, that it's to execute as the current user, auth ID current underscore user. Now the thing is, if there are Pl Sql objects attached to, say, a table or an index in this case, or whatever it happens to be, it will execute with the privileges of the owner of that table or index or whatever. So if we specify auth ID current user. So as a nefarious attacker, what we will do is basically on these tables create an index with a function-based index that calls, for example, grant DBA to public or whatever it happens to be. So because it will execute with systems privileges. So I'll give you a quick demo on this. But in real life, having researched this a bit further, I found that there's a table, xdb$ACL, which is owned by the XDB user. And if you have had an Oracle 9 database server and then upgraded it to 10 or 11, the permissions that were originally set on the install script for the XDB, the XML database stuff, it did a grant all on this table to public. Grant all includes select, insert, update, delete, and the index permission. Now, why is this so important? Well, if you're running a database with a virtual private database in it, and you've done an upgrade from 9 to either 10 or 11G, the permissions allow public to create an index on xdb.acl. And the XDB account basically has the permissions to execute dbms_RLS, which is used for defining virtual private databases. So as an attack, what we can do is come along and basically disable the virtual private database and gain access to the data we should not be able to gain access to. So that's why it's important. And also, code, it's like a Pl Sql tool and everything like that. I've seen every so often the index permission for public on the Toad plan table. But I can't work out where it's come from and why that's the case. But anyway, let's look at a demo. Right, let me just increase the console. All right. Okay. Okay, so I'm just going to do the setup first and explain what's going on. Right, so there is a table called, sorry, let me move that away. So let's say sys has a table called demo exploit table, and we will grant the select and the index privileges on it, and then, commit that. So that's how the setup complete. Okay, so now we're going to connect as this guy. Right, we should not be able to do a set role DBA because we don't have DBA privileges yet. Okay, role DBA has not been granted or does not exist. So we're now, recall that we have the index permission on the demo exploit table. So what we're going to do is, actually before we get there, let's create the nasty stuff. Right, this function here, let's explain what this does quickly. Okay, so we have a function we're creating called y that takes a parameter foo and it returns a type of varchar. Now it has to be deterministic in this case. If you're creating a function-based index, the function that's going to be on that index needs to be deterministic. Now what that means, well, it's irrelevant what that means right now, but the key here is pragma autonomous transaction. Now what that does basically, it tells the Pl Sql compiler that everything that this stuff does is fine to execute in its own little transaction space, and we're not doing anything untoward, nothing to see here, move on, move on. And what we're doing is granting the DBA permission to the Black Hat user. Now, I don't need to do a commit, but sometimes if I don't do the commit, it doesn't work, so it's in there for safety's sake. Now, coming back up here, what we do is create this index on the table owned by sys. Now what we're doing is creating an index called naughty index, and we're doing it on the demo exploit table, and what we're telling it to do is execute this blackcat.y function. Now remember, that's set as authID current user, so when we query the table, the demo exploit table, the index stuff will be called, and that function will be called, and it will execute with sys privileges. So that's just created the index. So now we just need to select from it. Now as soon as we hit enter, this function will be called in the background. Okay? So now our exploit should have worked out. We should have executed this function, this this stuff here. So we can do set role DBA, and we've now got DBA privileges. So if we do select star from session privs, we've got every privilege basically, whereas we didn't beforehand. So if I revoke DBA from Black Hat, because we're going to do several more, and then drop the index. Okay. So you can see how giving index permissions to a table, to public, or anyone for that matter, is dangerous, because it essentially gives them the ability to run code as that user. So don't do it. It's naughty. Right. So moving on to the next stuff. Okay. So I spoke about domain indexes earlier. It's the same. It extends indexing essentially. Now we're doing okay for time. There's a whole bunch of extended indexing on a default system. So both MD-sys, CTX-sys, XDB and XFS-sys, all these have their own index types that basically describe non-standard data, in other words, non-numbers, non-varchars, and so on. So these are used for things like the spatial application and the context application and so on. Now, essentially what is described by this, the indexing interface, is the Oracle data cartridge interface, and you basically build an index type that have these methods on them. And so, for example, we would have ODCI index create, which would fire in the background on the event of an index type, an index with that index type being created. Or if we dropped an index of that specific index type, the ODCI index drop would fire and so on. Now, if you look at every single, well, I say every single tutorial, I've not looked at every single tutorial, but the ones I have looked at, they all very neatly and nicely show you how to put SQL injection floors into your applications. It's even the Oracle ones. The Oracle tutorials teach you how to put SQL injection floors in your code. So if you, in your own bespoke or custom applications, have created your own index types and stuff like that, there's a very high chance that your versions of ODCI index drop and create and so on will be vulnerable to SQL injection. So if you're responsible for this kind of stuff, go back and take a look. Highly advise that. Now, if we look at another recent flaw discovered by Martin, CV 2011-3512, basically it's a bunch of spatial indexes, which is this whole domain index stuff. And on the event you drop an index, you essentially, the index has to have the arbitrary SQL in the name, and you enclose it with quotes. You can basically execute arbitrary SQL when you do the drop the index, because in the background the ODCI index drop happens, and that's when it embeds the name of your index into a block of PLC code and executes it. Now, because it's owned by MD-sys, you can't do a direct upgrade to a privilege upgrade to DBA. What you have to do is an indirect way. Basically, there's a table, system.ol$ that has public insert permissions on it, and what the MD-sys user does have is the create any trigger privilege. So what we do is create a trigger on this table, on the system table, for looking for inserts. So once we've created the trigger, and the trigger calls our nefarious function, which gives us DBA. So when we then insert into the system.ol table, the trigger fires, which calls our function, which then grants us DBA privileges. Now, I'm not going to demo that because I'm patched against that. I'm fully patched at the moment. So there's no point in me demoing that one. But it was fixed in October 2011. But if we look back in 2006, there were a bunch of flaws in the CTX-sys domain indexing space, whereby the same kind of issues were found. So, for example, the ODCI index drop and create and so on. You would think if you had a good security process in place, that organization would turn around and say, what else uses this stuff? Oh, look, MD-sys, the artery indexes and the spatial indexes, call this stuff. Oh, look, and we're vulnerable to SQL injection here too. They should have been more proactive about it and fixed it there and then, but they didn't. Okay. This one was patched in April 2012. I was hoping they were going to patch the other one, which I'm about to speak about, which is unpatched. But this one essentially is a classic stack-based buffer overflow. So if we alter an index and rebuild the online parameters and put basically a long string in there, it causes a stack-based buffer overflow. And I reported it in 2011, and they actually got it fixed really, really quickly within a couple of months. So doff my hat to Oracle there. And I'm not going to demo this one because I'm patched against it. But yeah, it's boring. It's a classic stack-based buffer overflow. You own the system. Don't tell anybody, but this one's not patched. So we create a table with a dodgy column name, dodgy being we put our nefarious SQL in there. We then create an index on the column, and then we run dbms stats against it. Now dbms stats goes about doing some of this ODCI stuff for us. We then drop the table and then bam, our SQL run. So it's a second order SQL injection as sys. So yeah, let me explain that. So I own the table, I own the index, but because it's sys executing it after we run the dbms stats on it, it's sys-owned stuff that executes, so we get sys privileges directly. So, yeah, before we get there, let's say I created a column called, and then quoted in double quotes, foo single quote bar, double quotes. What happens is, when we come to drop that index after running dbms stats on it, this is executed. Now, you can see that we've got a single quote, double quote, foo, single quote. So what that's done basically is broken us out of those single quotes, and then we can tack on our arbitrary SQL. So that's the anonymous block of Pl Sql that's being executed. That's where the flaw lies, underneath the covers. So if I come back here, and then reconnect. No, it's gonna be wrong. Connect. Black. / password. Okay. If I show you trying to set the role, we've not been granted it because remember we dropped the role from us earlier. So now, so I've created a table called Pwn Oracle, and you can see here the column name I've created is double quotes. We need to enclose it in double quotes. Foo single quote. This double this operator here, the double pipe, is the concatenator operator. So basically what we're doing is the result from the blackhat.x function is concatenated to foo, and then we concatenate bar onto the end of that. So that's what we're doing here. or that's what will happen in our second order SQL injection. And it's of type blob, basically. So we've created our table. We then create an index of type ctxsys.context. That's the index type. And we specify the name of the column, which is our nasty foo black hat stuff. So create the index created. So now, and this is the secret recipe, or the secret part of the recipe, we call DBMS stats on it, gather table statistics. Now what that does, see everyone's taking photographs of the exploit, nice. We basically gather the stats for this table. And in the process of doing this, it will also generate stats for the index as well. So that's that done. Now, when we come to drop the table, actually, let me go back because I want to show you in action. Drop table. Actually, this is going to fire it off, isn't it? Bugger. Right, let's just do it. Right. And I'll come back and show you. Right. So essentially what I've got is a function here called x that, again, it's using that auth ID current user, granting DBA to public, to Black Hat, and we're calling that x function, basically. So when I do this, that would have executed my x function, so I can now go set role DBA. And so I'm DBA again. Okay, so that's... Thank you. See, the thing is, I feel like a bit of a fraud because I used to do buffer overflows, and now I'm hacking Oracle. You know, it's trivial. You know, I mean, it's not like you're poning Chromium here or anything like that. You know, so as I said, I feel like a fraud. You know, so I'll show you this in. Let's just simply do one. Remove that. Right, here we go. So, whoops. Yeah, this is basically just to show you it, the error you would get, and that's how I, realized it was going to be exploitable. Right, create the index. Yeah, I've got two, thank you. Okay, that's the index. And then pun one. Okay, and then pun one, Control C. So we get an error basically. See here, error occurred at recursive level, because what it's trying to do is it embeds that foo single quote bar in there, and essentially chops this off, making this like an identifier kind of thing there. So we get identifier, we get a bit of the code coming back out, so we can see that it's vulnerable to SQL injection, and then from that point onwards, it's guaranteed we own the system. Okay. What are we doing for time? Okay, I've finished. So, yeah, are there any questions on that stuff? Sure. Is there a microphone at all? No microphone, no? All right, could you go up to there and ask the question, just so everyone can hear it? Or I'll repeat the question.
Can you talk about the methodology that you used to find, how did you audit? Do you have automation?
Yeah, okay. So we have a tool that basically unwraps the Pl Sql, and it just reading through it. But to be fair, that stats one I found just by playing with the system, and dropped the index, and it was like, oh, something went wrong there, and having to go back and reread through it, and then, so that the DBMS stats one specifically was a just happenstance kind of. So, but normally it's like reading through the code and stuff. Sure.
Last year's talk was database forensics. Are you leaving behind any interesting traces?
Yeah, you absolutely are. And I just need... Sorry? Yeah. I'll wait till everyone's gone. So yeah, the question was, are you leaving any interesting traces behind as far as forensics are concerned? Yes, you are. You're creating indexes, leaving evidence in the sys objects tables, and if you drop them, once they're deleted, we can still find them again and everything like that. It's not the interesting part though, and there's nothing new in that technique, which is why it's not in there. So, any other? Who wants to know what I did to my hand? That was the last photograph I took with the camera, and when he bit me. That's a 12-foot great white shark, and yeah, that's the shot. It died. I'll show you the camera.
You still have all your fingers?
Yep. So this was coming up after the dive. That was me. I got bit by a great white. That was just before it bit. So that was it coming around, and I was like, great, it's going to swim over the top, and I'll get a great shot of its snout, and then bam! And that was my camera on the top, and the scratch marks down there, underneath. So this is a 1/4-inch alloy, and it punctured through that part there, and it left a bit of tooth embedded in there, and obviously you can see in there and stuff like that. It crushed the housing in there. That was a couple of days after. Yeah, that was the shark. So, but essentially what happened was, when it bit, I didn't actually realize I'd been bitten at the time, and my girlfriend was in the cage next to me, and she was like, "You fucking idiot." And I was like, I got bit by a great white, and and then I'm taking more photographs. This is where is it? So this here is the last photograph I took of it. Now you can see the glow around the bottom. That's because the camera housing had leaked and it was ruining the camera. And I noticed that it was leaking. I was like, oh, God damn it. So I said to the DM, let's go up. So we went up, and it was only when I got to the surface that my hand actually started bleeding because of the water pressure. We were down at 60 feet, and the water pressure had basically stopped, any bleeding under the water. So I was like, oh, look at my camera. Oh, look, there's a bit of tooth. And then suddenly there's like this, and I'm like, ah! So yeah, my camera survived for about 10 minutes because it was just a very, very slow leak. And so yeah, that was the last shot that my camera ever took. But the housings, I've repaired the housing now. I've got a G-clamp and a screwdriver and a bit of brute force, and yeah, it's back in business. So yeah. Anyway, the hand was broken before as well, but then the shark bit it, so it wasn't very nice. Yeah. Okay, well anyway, thank you very much for coming, and sure.